So I've put these results into Logger Pro to graph them. You could have done it in your book just as easily. I've done the mass instead of in grams, I put it to kgs. I divided it by 1,000 and plotted that. Looks pretty linear, so it looks like I can just straight away for this graph add in a line of best fit. Instead of doing any sort of transformation, it's a line of best fit. And what have we got here? My slope is 9.832 newtons per kg. That makes sense because it's rise newtons over run kgs. I'll just round that off to 9.8. Intercept goes through 0, correlation of 1. That's some great data, really good data. So I'm going to sketch that graph and just remember this number off by heart. The slope of it is 9.8 newtons per kg. And I'm going to do it on here. So my graph, and you've already got your graph hopefully on Logger Pro or in your book. You should have a little sketch of what it looks like. Force in newtons, mass in kgs. It was a straight line. The gradient was 9.8 newtons per kg. And the equation therefore becomes y equals mx plus c. Y is force of gravity. Let's do it like this. The force of gravity is equal to m is the slope, 9.8 newtons per kg, and x is the mass times mass. Now that's what you had in year 11. In year 11 you used to say, oh, if my mass was 80 kgs, I times it by 10 and that equals 800 newtons. That's where this comes from. It comes from this experiment where you've got your mass here, and instead of timesing it by 10, the actual number we found today is 9.8 newtons per kg, and that gives you the force of gravity on you, or another word for that is weight. From now on, whenever we talk about 9.8 newtons per kg, we're going to say it properly. You don't say gravity equals 9.8. That is wrong. Okay. You say the force, you say the gravitational field strength. That's the name of this thing here. Gravitational field strength. And that equals 9.8 newtons per kg. Another way of saying it is that it equals 9.8 newtons for every kg. I'd like you to be saying it like this. So the gravitational field strength on Earth is 9.8 newtons for every kg. The reason you say it like this is because whenever we deal with that number, if you say 9.8 newtons for every kg, you remember, oh, I'm 80 kgs and it's 9.8 newtons for every kg. I better times that by 80 to find what my gravitational force is, not just the gravitational field strength. So many people go to draw force diagrams of a person, and then when they put the numbers in for the force of gravity, they say, oh, their gravity is 9.8. No, because this is not the force of gravity. This number here is the gravitational field strength, which is 9.8 newtons for every kg. Great. I would really like you to write down this at the end of this experiment. Thank you.